use L'Hopital's rule to find the next limit. L'Hopital's rule says that when limit is 0 over 0, such limit is equal to limit the derivative of the numerator divided by the derivative of the denominator. So let's check. When x is 0, we get secant of 0. Secant is 1 over cosine, so 1 over cosine of 0 is 1, minus cosine of 0 is also 1, so 1 minus 1 is 0, and the denominator is also 0. So we get that this limit is 0 over 0, so L'Hopital's rule can be applied, and hence this limit becomes limit x tends to 0, and we need just find the derivatives of the numerator and of the denominator. And the derivative of the numerator becomes, we can see that it's what, secant to the power of 4, and we should consider it as some function to the power of 4, and we should apply a chain rule. And the chain rule says that function to the power of 4 derivative, it's what, 4 function cubed and function derivative. So it becomes 4 secant cubed and secant derivative. Formula is given in a data booklet, and secant derivative is secant tangent. So we get 4 secant cubed of x multiplied by secant derivative, which is secant of x multiplied by tangent of x, minus same formula because it's again function squared, so it's minus 2 cosine multiplied by cosine derivative, which is negative sine, so it's plus sine of x, and the derivative of the denominator becomes just 4x cubed minus 2x. And let's just rewrite it and simplify, so it becomes limit x tends to 0, and we can see that it becomes 4 secant to the power of x multiplied by tangent of x plus, and we can see that it's directly a formula sine of 2x, and we can apply it. It's not necessary, but if we apply it, we get only one function instead of a product of two functions, and it may be usable, sine of 2x, and divided by 4x cubed minus 2x. And as usual, we substitute 0 for x, and we can see that it becomes tangent of 0 is 0, sine of 0 is 0, so we get 0, and the denominator is also 0, so we get 0 over 0, and we should apply L'Hopital's rule again, and it becomes limit the derivative of the numerator divided by the derivative of the denominator. So we need to find derivatives again, and the derivative of the numerator becomes, we can see that it will be derivative of this plus the derivative of this, and derivative of this, it's what? It should be considered as a product because secant multiplied by tangent, and we should apply a product rule, and it says that it becomes 4 secant to the power of 4 of x derivative multiplied by just tangent plus 4 secant to the power of 4 of x multiplied by tangent derivative, and plus sine of 2x derivative. It's not necessary to write, so let's calculate. So 4 secant to the power of 4 derivative, it's again chain rule, so it becomes 4, this 4, and secant to the power of 4 derivative, it's 4 secant cubed of x, and secant derivative, which is secant tangent, and multiplied by this tangent, plus 4 secant to the power of 4 of x, and tangent derivative, which is secant squared of x, formula is given in a data booklet, plus sine of 2x derivative, it's chain rule, but for function of more complicated argument, and we use the same formula as for sine for derivative, but multiplied by argument derivative, so it becomes cosine of 2x derivative, which is 2, so 2 arises in front, and the derivative of the denominator, it becomes just 12x squared minus 2, and is equal to, let's just simplify and rewrite. And actually it's not necessary, you may just substitute 0 for x directly into the obtained expression, but let's rewrite it. It becomes 16 secant to the power of 4 of x tangent squared of x plus 4 secant to the power of 6 of x and plus 2 cosine of 2x divided by 12x squared minus 2. And now we substitute what 0 for x, and we can see the tangent of 0 is 0, secant is 1 over cosine, cosine of 0 is 1, so it's just 4, plus cosine of 0 1, so 4 plus 2 divided by 0 negative 2, and we can see that it's just negative 3. And that's all for this question.